Welcome to Brain Vision.
This is the problem number 8. In this problem, suppose you add a constant V naught to the potential energy. Let's assume the potential energy is V, VA, xt, and now you add a constant, that is V naught, in this potential energy. So this is uh, poten- potential energy, which is the function of the SNT, and it is constant, that is independent of the position and the time. Let's assume this is V, and the corresponding wave function is psi. Let's the corresponding wave function is psi xt. And in classical mechanics, this does not change anything. But what about the quantum mechanics? And so that the wave function picks up a time dependent factor, that is e power minus I v naught t by h bar. What effect does this have on the expectation value of the dynamical variable? So we have to show that there is a dependent factor of the time, that is e power minus I v naught t by h bar. So let's do this problem. We know the Schrodinger wave equation. We have time dependent Schrodinger equation, that is E psi is equal to S I, and the value of E is, that is I s bar del by del t, that is del psi by del t here, is equal to minus h bar square by 2m del 2 psi by del x square. This is the kinetic energy, plus V psi, that is here. When we don't add this V naught, let's suppose this is V xt psi. Now calculate from here, that is del psi by del t is equal to, this will be I s bar by 2m del 2 psi by del x square, plus this will be 1 upon I s bar. If I multiply by I on the numerator and the denominator, then it will be minus I by h bar and Vx t and psi. So this is the Schrodinger equation when we don't add the some constant into the potential energy. So this is the equation number 1. Now we add a constant. We add a constant V naught to the potential energy, and let's assume the corresponding wave function is psi naught. Is psi naught. Then we will write this Schrodinger equation again, that is del psi naught by del t is equal to I h bar by 2m. So here there will be no change in the kinetic energy because we don't add anything to the kinetic energy, that is del 2 psi naught by del x square minus I by h bar. Now this Vxt is replaced by Vxt plus V naught, and the corresponding wave function is psi naught, that is xt. So here we will write this psi naught xt. Now we can write this into two parts. Here that is del psi naught by del t is equal to I h r by 2m del 2 psi naught by del x square minus I by h bar Vxt and minus psi naught xt minus I by h bar V naught psi naught xt. Let's write this here. Minus I by h bar, and this is V naught and psi naught xt. Let's write this right hand part to the left side, this side, then it will be del psi naught by del t plus I by h bar V naught psi naught xt is equal to IH bar by 2m del 2 psi naught by del x square minus I by h bar Vxt and psi naught xt. And this side, that is left hand side, is the first order equation in the time, that it is first partial differential equation in time, and the solution of this part can be written, the integration factor of this will be if is equal to exponential 0 to t, and this, that is this constant, suppose this is m, so this will be m dt, that is I V naught by h bar and dt, and this will be, that is t, and here we will get that is exponential I V naught by h bar and t, and this integration factor can be used to solve this equation, and we multiply this equation. Let's suppose this is the equation number 2. Now multiply equation 2 by integration factor on both sides, multiplying equation 2 by integration factor on both sides. Then you will get I exponential I V naught t by h bar dot del psi naught by del t plus I V naught by h bar psi naught xt and exponential I v naught t by h bar is equal to I h bar by 2m exponential I v naught t by h bar del 2 psi naught by del x square minus I by h bar exponential I v naught t by h bar into vxt and psi naught xt. And here you can see that this left hand side part, that means suppose this is the first function, so here that is first function, then the derivative is second, and plus del psi by del no del t, that is I v naught by the derivative of this I v naught by h bar, and psi naught xt is constant. That means we can write this as a derivative of time, that is del by del t and psi naught xt and exponential I v naught t by h bar. And if you do differentiate it, that is psi naught is constant, the derivative of this, that is e power e I v naught t by h bar and dot I v naught by h bar. So this is here, psi naught constant here, and again e power I v naught t by constant, and the del psi naught by del t is here, and it is correct. And right hand side is I h bar by 2m and exponential I v naught t by h bar del 2 psi naught by del x square and minus I by h bar I v naught t by h bar vxt and psi naught xt. Let's assume this is the equation number 2, 3, sorry 3. Now compare equation 1 and 3. This is the equation number 1, when there is no constant added in this potential energy, and here this is the equation number 3, when you add the some constant into the potential energy. Let's compare equation 1 and 3. Then you will get, because this is del by del t and this is some wave function here, so here this is del psi by del t, that is the psi xt is equal to, you can see this right hand side is same in the both, so hence psi xt is equal to exponential I v naught t by h bar and psi naught xt. Now we have to find out this psi naught xt. Psi naught xt is equal to, that is exponential minus I v naught t by h bar and psi xt. So hence the a term is added in the term, that is extra term, that is e power minus I v naught by t by h bar, present because of a term which is added into the potential energy. And this wave function is the wave function when there is no term added into the potential energy, and this is the wave function corresponding to the potential energy when you add the some constant in the u, that is v naught. Now we have to find out the expectation of the dynamic variable of a particle, and we have, suppose q x p. Q is the dynamic variable, which is the function of the position and the momentum, and it is given as minus infinity to plus infinity, and psi naught complex conjugate xt and q x and p is minus I h bar del by del x psi naught xt and dx. Now substitute the value of the psi naught, and that is complex conjugate minus infinity to plus infinity psi naught complex conjugate, that is e power plus I v naught by h bar and psi xt. So this will be exponential plus I v naught t by h bar and psi complex conjugate and q x minus I h bar del by del x and the psi naught xt, that means exponential minus I v naught t by h bar, and this will be here psi xt, this is psi, this is also psi, and dx. This term is cancelled to each other, so here you will get only two term, that is minus infinity to plus infinity psi complex conjugate and the q x minus I h bar del by del x, and here psi by dx, and which is the expectation value of the q. So the hence this is same, that is expectation of the q xp is equal to minus infinity psi star and the q psi dx, and this is the same because here the wave function is uh, corresponding to the original wave function when you not add the constant potential to the potential energy. So that means there is no effect on this expectation value of the dynamical variable. Thank you.